Hello everyone, welcome back to your channel The Khadiya Insan. So in the previous video we had seen the implementation of the LangGraph incremental summary memory, right? So today we'll be starting with our stage 7, that is the persisting the memory. If you would have seen my previous video, we were able to maintain the context, right? We were able to summarize the message, but till the Python service was running till then. If we restart the service, we were losing the context, right? Because why? We were creating an in-memory server, right? In-memory saver, not persisting in our database. So today we'll be looking at the approach how we can persist that context, and even if when we restart our Python service, we are able to get that context, right? It doesn't lose, right? So for that, we'll be using the PostgreSQL database. Okay, so we'll persisting our context, our history in the PostgreSQL database. Now you will be thinking, why PostgreSQL, right? Why not MySQL? He said this PostgreSQL give us with additional capabilities. Okay, capabilities of storing the vectors. Okay, now what is this vectors? We'll see in the existing upcoming videos. Okay, and thereby we can perform similarity search. Those who are aware of this terms, they will be able to relate, right? Thereby perform similarity search. So don't worry, in the upcoming video we will get more clarity like why we are going with the PostgreSQL database rather than MySQL. Okay. So now see, so setting up this PostgreSQL. Up this SQL. See, there are three options. Normally as we download, right? Normally as we download MySQL software in our system, right? MySQL software. See, these are the traditional approach, right? Another is okay, we can create an instance, an RDS instance in the AWS, right? In the AWS RDS and Aurora service, right? But this will cost us, right? Service. This will cost us. See, we can go with this in the production, but as now we are learning phase, so let's save the money, right? So the other approach is Docker. Okay, so we will be going with this Docker concept. So before first, I will like to give you the short context on the what is Docker. See, Docker is wrapping up the code. First, understand the simple way. Wrapping up the code and the environment required to run the code in a single, so that it can run anywhere without setting up the environment. Without setting up the environment. Okay. So what we'll be doing is we will be downloading the Docker image for PostgreSQL database. Now when I say image, what does this mean? It has the dependencies and the environment required to run this database. Okay, I am not mentioning it code because it's not necessary. Code may get wrapped. Okay, the code may get wrapped. Just to give you a intuition, I gave this, right? Wrapping up the code and the environment required to run the code in a single unit so that it can be run anywhere without setting up the environment. Okay, so this image, this image can be considered as a template. Okay, just like a class in Java, right? So it's not ready to execute, but has everything required to execute. Now we have containers. We have containers. So through this, we will run the Docker image, right? Just as we create object for the class and execute the class, right? So this is what you want to do. Okay, so we want to install the Docker image, download the image for Docker for PostgreSQL and create the container for it, and inside that will work. Let's start with this. So see, for this, first of all, you will need to install is Docker Desktop. See, install this once and get ready to use all the softwares. Okay, download all the softwares. So what is this Docker Hub? Docker Hub. Let me type down this also. Docker Hub can be a repository where various public images are available. Right. So similarly, public image for setting up PostgreSQL database in our local available here. Okay, let's start. So, so first we'll have to pull the image. So this is the command to pull the image from the Docker Hub. Okay. See, I have already in my system this image installed. Okay. So this is the command for pulling the Docker image. Now what we will do? We will run the container, right? Because this is the just a template. To execute it, we need to run it, right? So let's first see I have already a container created or not. For that, the command is this. So if you see here, I have already a container created. Here, right? Its name is memory Postgres. So we will just start this container. Docker start memory Postgres. Okay. So, so the container is started, right? Now let's check whether the container is running or not. So see, this container is running, right? 5 seconds ago it started, right? So now we will be going inside this container and we'll be connecting to selecting a database that is a memory DB. Okay. So we'll be going inside the command line of this database. Okay. CLI. Okay. CLI we write commands and execute, right? So inside this I am going through this I am going. This is the password username Postgres to enter into the CLI and I am selecting the database memory DB. Okay. See, now we have come inside, right? Now we can write here the various commands. Let's first see what are the different tables present in this DB. Okay. So if you see, these are the database already present. Okay. So first I would like to clear the existing data, right? Because I had also tried before writing code here, right? So I will clean it. For that, all truncate table points with point blobs, right? So this is there. So now we will be writing the code that will persist our context in this database and we will restart the server and we will see that yeah, are we able to preserve the context after switching off the session or not. Let's start writing the code. So before that, we will also have to install the packages, right? Dependencies to set up this Postgres checkpoint, right? So this is the command for installing it. Okay. So I have already installed this. You can type this command to install this library. Okay. So from LangChain underscore core dot messages. What will you putting here, sir? Are you able to relate? Some message. Some message. Now from LangGraph dot graph. What we are importing? Do you remember? So importing messages state. Messages state, right? Start, then state graph. And all this purpose I have been repeatedly telling the video, right? Now from LLM, port get LLM, right? Now we want to import the check pointer also, right? So from LangGraph dot checkpoint import Postgres or check down. I write down the import correctly or not. This one. Yeah. Now getting the client connect to the foundation model. So now let's define a node, chatbot node, right? Chatbot. So it will take the state as the input, that is the message state, right? And will update it and send, right? Let's say messages equal to state state of message, right, sir? Done. Let's write the system message for the LLM, right? So to system message content equal to. So you are a, let's write the simple prompt. You are a helpful AI assistant, right? Please keep your answer short, right? The system message. So now let's prepare the final message that we send to the LLM, right? So it will be a list of tuples, right? So first we will send the system message, and then we will be expanding the messages list, right? So then we will do response to LLM dot invoke. What we will invoke is final message, and at the end we will return. What will return? Return messages. All these things we are repeatedly doing, right? There is nothing to again talk about. Now, so now we will create what is the URI to connect to our database, right? So the URI is this, right? We are locally running it, right? So this is the URI. The memory DB, we selected the database memory DB, right? Memory DB with with PostgreSaver dot dir. So we are trying to locate a resource. So from this connection string, we are locating a resource, that database, and we are assigning it to the check pointer variable. Just like if you are from a Java background, there is try with resources, right? So there what we are doing, we are locating a resource for some time, use it, and after some time we are releasing it, right? So same concept here. From the database, from this connection string, we are locating a database, assigning it to the check pointer, will perform some operation, after some time we will release it, right? So that's the concept. So now first create the graph equal to state graph. And what is, for what state graph is this? Messages state. Right. Now builder dot add node. Right. Chatbot chatbot. Now builder dot add age. After start we want this node to be executed, right? We registered the node with the graph, and now after start we want chatbot node to be executed. Chatbot node to be executed. Now we will compile. Graph is equal to builder dot compile, right? Check pointer check pointer to check pointer, right? So what we are doing, we are compiling the graph with this PostgreSaver check pointer, right? Okay. So rather than before, first we what did, first we are not able to save the context. Then we went with memory saver where we created a in memory, right? In memory means after stopping the server, the context will lose. But till the server is running, we were able to preserve the context. Why? Because after each graph invoke, we were checkpointing that right to the in RAM memory. So now where will we checkpointing that? To our database. When after stopping the servers, we will able to retain that. Check that. Now while true, our regular loop, sir, put put now input over to exit. Then what? Right, right. Else graph dot invoke what messages of what tuple, right? Tuple, that is their uh, their input. So remember, we have forgot one other thing, that is the config here. We need to provide here config also, right? Config. So we need to create a config variable, which is the thread ID, right? Config equal to config variable to thread ID to wow. So now we will give right. Check. So this is the right, and we will assign it to the result. Now that. So now we will be printing the response. AI response to what? The result is a dictionary, right? From that we want messages key. That is what a list. So in that list, I want the last element to be printed. So we got that tuple, and in that we want to print the content part, right? Okay, let's run it. Where we stand is going to create that connection, trying to locate the resource. So hi, my name is Dubey. See, hello Ankit, nice to meet you. Okay, so now let's exit the conversation and restart it. Right? See, we have stopped the server. What is my name? Your name is Ankit Dubey, right? See, even after stopping the server, we restarted the server, but it is able to remember my name. Why? Because now instead of checkpointing to the in-memory saver, we are checkpointing to the PostgreSaver. We are persisting our context in the database. So even after restarting the server, we are not losing our context. So this is what is the concept of long-term memory. The previous video, I had shown you the concept of short-term memory, summarization, right? Short conversations. Like user is talking on multiple topics, kind of summarizing it, right? But that is till the context, till that thread is running, right? Till that only. But this we want it to be saved. When we restart the servers, we want it to be saved. Like suppose you go to the chat GPT, you talk about multiple things, right? But it remembers your basic things like your name, what are your interests. Why? Because that it is persisting in its persistence memory, right? Okay. That what was my idea through this video to bring in it. So that's all for today. Keep coding, keep exploring. Hariya Insan, signing off.